Welcome to ScientiFlow. In this video, you will learn how to perform a protein ligand molecular dynamics simulation using the ScientiFlow Execution Mode in just a few clicks. Before starting the simulation, the only input required in ScientiFlow is a protein ligand docked complex in a single PDB file. Make sure that both the protein and the ligand are present together in one PDB file, representing the docked complex. This file will be used as the starting structure for the molecular dynamics simulation. In this demonstration, I will show you how to run molecular dynamics simulations for two protein ligand complex samples using ScientiFlow. Once you have created your account, navigate to the Projects section. Click on New Project, enter a project name, and choose the required template. Then click Create Project. After creating the project, open it to create a new job within that project. To create a new job, click on Create, and enter a job title. Select New Job, specify the job directory, and then click Continue to proceed. Once you navigate to the next page, select the pipeline mode of execution. For the protein ligand MD simulation, you can choose one of three options: with analysis, without analysis, or only analysis. Choose based on your need. If you only want the protein, you can select the ApoProtein MD simulation. Again, you have three modes: with analysis, without analysis, or only analysis. Finally, for a comprehensive plot visualization, you can select the comprehensive plot visualization option. Once you choose the protein ligand MD simulation with analysis, select Continue and navigate to the next page. Here, you will find an option to upload your sample. Select the Upload option, click Upload, and choose your sample file from your local machine. Next, enter your simulation timescale. For this demonstration, the simulation timescale is set to 1 nanosecond. After that, define the GMXMMPBSA analysis by specifying the start time and end time for the calculation. For example, if your total simulation time is 100 nanoseconds, the last 10 nanoseconds can be used for the GMXMMPBSA analysis. Since the simulation timescale in this run is 1 nanosecond for purpose of demo, the start time is set to 0.92 nanoseconds and the end time is set to 1 nanosecond. After that, keep the number of threads as the default value, and then navigate to the next page. Once you navigate to the next page, you will have the option to select the job execution mode. There are two modes: ScientiFlow Execution and Self-Execution Mode. In ScientiFlow Execution Mode, you don't need any special infrastructure or subscription. You simply pay for your sample, and you have the option to calculate the cost beforehand. Once you pay, you can run your sample directly on the ScientiFlow platform. In contrast, the Self-Execution Mode requires you to have your own infrastructure. You need a GPU-supported system, and you must purchase a subscription to run your sample independently. In this video, we will use the ScientiFlow Execution Mode. When you scroll down, you'll see a pricing calculator. Here, you can upload your sample by selecting the file from your local machine. After that, you enter the timescale for your MD simulation, and then you can calculate the estimated price for your sample. Once you've estimated the price for your simulation, navigate above and select the option to buy more credits. Here, you can enter the amount of credits you need based on the estimated price. Once you've chosen your amount, select Proceed to Payment. This will take you to a page where you can complete the purchase of your credits. After your credits are fully purchased, you can submit your job. Keep in mind, if you don't have enough credits to run all your simulations, the job will not complete. So, if you plan to run multiple complexes, make sure you upload each one, calculate the estimated price using the pricing calculator, and purchase credits accordingly before you run the job. For execution. Now, I will submit another protein ligand complex for simulation by following the same procedure. Once your simulation starts running, you will receive a notification by email. You will also be notified again by email once the simulation is completed. To view the results, open your project and navigate to the Submitted Jobs section. A tick mark will indicate that your job has been successfully completed. You can download the raw output files directly from here within the same workspace. Now to generate publication-ready images, you have to create a new job under the same project. Enter the job title and specify the job directory, then navigate to the next page. Under the pipeline mode of execution, select Comprehensive Plot Visualization, and then click Continue to proceed. Next, select the job directories for which you want to generate plots. If you want combined plots for multiple simulations, select all the required job directories together. If you want plots for a single simulation, select only one job directory. Below this, you will find the option to enter the display name. Enter the name as you would like it to appear in the plot legends. Next, choose the colors for the plots by entering the color code in hex color format. Then select the preferred legend position according to your requirement, and click Continue. On the next page, select the job execution mode. Choose the ScientiFlow Execution Mode, and then click Submit Job to generate the plots. You can directly submit the job. Once the job is completed, you will receive an email notification. The plot generation results are delivered much faster compared to the simulation runs. You can download the generated plots directly from the same interface. Once you open the downloaded file, you will find all the publication-ready plot images. Since two job directories were selected together, the plots have been generated as combined comparative plots. As the simulation timescale was set to 1 nanosecond, the plots have been generated accordingly for the 1 nanosecond duration.